Hello friends, welcome to Edupedia World's video on dot situation in our series of logical reasoning videos. This is part 3 of this video set, and in part 1 and part 2 we have seen how to solve single dot, double dot as well as triple dot problems. Now in this part 3 we will see a few more triple dot problems so that we'll get some good practice on solving these kind of problems, and we'll see various types of problems that can come. So let's start with the example on our screen. Now this is a relatively simple one. We have only three shapes in this example. We have a square, a circle and a triangle, and there are three dots in this figure X. Now let's take a look at the reasoning process. Okay, how should we go about eliminating the incorrect options? Okay, always remember the best way to solve problems in any competitive exam is to use the method of elimination, okay, so that you can eliminate the options you're sure are wrong, and then you can select among the options that remain. So for the first dot, the one towards our left, the condition states that the first dot lies inside the area covered by the square and the circle only. Okay, so this dot does not fall within the area of the triangle. Now let's see which among the four alternatives have a common area between the square and the circle where the triangle is not present. We see that in figure 1 such an area is present. Okay, if you see this area being pointed to by the cursor, this is common between the square and the circle, okay, and the triangle is not present here. So I can keep option 1. In option 2 I see there is no such area. Okay, the area in the overlap of the circle and the square is also covered by the triangle. So I can eliminate option 2. In option 3 I see that yes, there is an area that is exclusive to the circle and the square, and the triangle is not present there. So I'll keep option 3 as well. And in option 4 also I see that there is a very small area over here. It forms a part of a circle. So in this small area the triangle is not present and it's only the square and the circle. So on the basis of the first condition I have been able to eliminate option 2. Okay, so I will no longer check option 2 for any of the problems. Okay, now I just have to choose between 1, 3 and 4. Now the second condition states that for the middle dot, the second dot lies within the area covered by the circle only. Okay, so now I have to see which of the remaining options, that is 1, 3 and 4, have area that is covered by the circle only. So I see that in option 1 there is some area that is exclusive for the circle. Similarly in option 3 there are two areas, one towards the top, one towards the bottom, which are covered only by the circle. So I can keep both of these options. And in option 4 I see that there is no area which is exclusive to the circle, okay, where no other shape is present. So I can eliminate option 4. Now after the checking for the first two conditions, I have been able to eliminate option 2 and option 4, and I am left with option 1 and option 3. Okay, now I'll check the third and final condition, which states that this dot, the one on the right, the third dot, lies within the area covered by the circle and the triangle only. Okay, so for this dot it should be placed in the common area of the circle and the triangle where the square is not present. Now if I see the first one and if I see the common area between the circle and the triangle, I see that the square covers the entire area. So I can't place this dot in figure 1. So I have to discard that. And now if I check option 3, then yes, there is a common area between the circle and the triangle where the square is not present. So I have to select option 3 as the correct choice, and I will place the dots in such a manner. Okay, I'll place one dot in the area common to the circle and the square. I'll place one dot in the area common to the circle and the triangle, and I'll place one dot in the area covered exclusively by the circle, either here or here. Okay, that is your choice. So now this was a simple example of three figures and three dots. Now in our next example, again we have four figures, and this is slightly more complicated than the previous question. So as you can see, there are four figures here. Okay, we have a circle, we have a square, we have a triangle, and we also have a rectangle, and we have 3 dots. Now we have to check the conditions and we have to eliminate. Now remember friends, a figure may look complicated, but if we break it down into simple logical steps, each question is very simple. Okay, so we just have to check for the conditions. Okay, so now in this question also there are 3 dots which have their own conditions. So the first dot, which is on the left, follows condition number 1, which states that the first dot lies inside the area covered by the square and the circle only. You know, when I say covered by the square and the circle only, I mean that the remaining 2 figures, that is the rectangle and the triangle respectively, are not present. Okay, where the dot has to be placed. So now I will check all the 4 options and see which option has an area that is covered by the square and the circle only and no other figure is present there. So if I check option 1, I see that in the area common to the square and the circle, the rectangle also covers that area. Okay, so it is not exclusive to the square and the circle. So I have to eliminate option 1. Now when I check option 2, I see that there is an area, okay, that is exclusive to the square and the circle. I see that the square is inscribed in the circle and the triangle is inscribed inside the square. So there is quite a lot of area which is not covered by the triangle and it is exclusive to the square and the circle. So I can keep option 2. Now when I check option 3, again I see that yes, the square and the circle do have 2 areas that are exclusive to them. And similarly in option 4, there is a sector which is exclusive to the square and the circle. Okay, only these 2 figures overlap that area. So I have been able to eliminate option 1 using the first condition. Okay, we'll go step by step and then we'll check for the second dot, the one over here at the bottom, and we'll see the condition for that. So the second dot lies within the area covered by the circle and the rectangle only. Okay, now let's check which of these figures, the ones that we have not eliminated, have area common between the circle and the rectangle only. So I can see that in option 2 there are 2 areas that are common only to the circle and the rectangle, so I can keep option 2. In option 3 also there are 2 small areas where only the circle and the rectangle are present, so I can keep option 3 also. And in option 4 also, okay, there is quite a big area that is common only to the rectangle and the circle. So using the second condition, I have not been able to eliminate any option, which means using the third condition I will have to arrive at my answer. So the third condition is for the dot towards the right at the top, and the condition states that the third dot lies within the area covered by the triangle and the rectangle only. Okay, so as you can see here, this dot is placed in such an area that falls within the area of the triangle and the rectangle only, and the square and the circle are not present over there. So let's check the 3 options. Okay, which options have an area common to the triangle and the rectangle. Now we see in option number 2 there is no area which is common to the rectangle and the triangle. Okay, they don't have any overlap at all, so I can eliminate option 2. Okay, now I'm left with options 3 and 4. In option 3 I see that there is an area common to the triangle and the rectangle, but the circle is also present over there. Okay, that area is also covered by the circle, so I can eliminate option 3. When I check option 4, again I can see that there is quite a big area that is common to the triangle and the rectangle, okay, when no other figure is present. So I don't have the circle and I don't have the square in this area being highlighted by the cursor, which is common to the triangle and the rectangle only. Okay, so I can go ahead and I can place dot number 3 in this area. Thereby I come to the conclusion that the answer has to be option 4. Okay, so I'll place one dot in the area common to the circle and the rectangle. I'll place another dot in the area common to the square and the circle, and I'll place another dot in the area common to the rectangle and the triangle, thereby solving my problem. So as you can see friends, if we go step by step logically, these kind of problems are very simple to solve. Okay, now let's take a look at one final example before we wind up. So again we have four figures here. We have a rectangle, we have a triangle, a square and a circle, and we have three dots placed over there. Now let's see the reasoning process for this problem. Okay, now let's start from the left, and we see that the first dot lies in the area covered by the triangle and the rectangle only. So I will check my options and I will see which of the figures have an area that is covered by the triangle and the rectangle only. Now I see in figure 1 there is quite a big area that is common to the triangle and the rectangle, this one being highlighted by the cursor, and no other figure is present over here. So I can keep option 1. Now when I check option 2, again I see that there is some area that is common only to the triangle and the rectangle. Okay, this small area on the right and the corresponding small area on the left. So I can keep option 2 as well. When I check option 3, I see that again there is quite a big area that is common to the triangle and the rectangle. So I can keep option 3 as well. Whereas in option 4, there is no overlap between the triangle and the rectangle. So using condition 1, I can eliminate option 4, and now I'm left with options 1, 2 and 3. So now I will go ahead and I will check the second condition. So I see that the second dot, that is the one in the center, lies within the area covered by the circle and the triangle only. So upon checking option 1, I come to see that there is quite a big area that is covered only by the triangle and the circle. So I'll keep option 1. The same is true for option 2 also. Okay, on top if you see this area, this is covered only by the circle and the triangle. Okay, no other figure is present there. It is outside the area of the square. It is also outside the area of the rectangle. So I'll keep options 1 and 2. And when I check option 3, I see that there is no overlap between the circle and the triangle. So I can eliminate option 3. Okay, so using the first two conditions, I have been able to eliminate options 3 and 4, and now I am left with option 1 and option 2. Okay, so now when I evaluate the third condition, I see that the third dot, that is the one on top over here, lies within the area covered by the triangle and the square only. Okay, now when I see the first diagram or the first option, I see that the triangle and the square do have quite a big common area between them. Okay, and no other figure is present there. Whereas in option 2, since the square is inscribed in the circle, the common area between the triangle and the square also has a circle over there, and the rectangle is also present there. So in option 2, there is no area exclusively covered by the triangle and the square. So I have to eliminate option 2, and I will be left with option 1, which will be our answer. So I'll place one dot to the left in the area common to the triangle and the square. I'll place one dot in the center in the area common to the circle and the triangle, and I'll place one dot to the right in the area common to the triangle and the rectangle, thus solving my 3-dot problem. So I hope this video has been helpful for you friends, and after watching this set of 3 videos, you will be able to answer all kinds of dot situation problems. I look forward to explaining another concept to you in a related video on logical reasoning. Thank you for watching this, and I'll see you in another video.